Before we start on part 2 of exponents, we want to look at 3 preliminary methods. The first one is writing improper fractions as proper. Let's take an example. Let's say we have 2 3/4, which is an improper fraction. We can write this as a proper fraction as follows. 4 times 2 is 8, plus 3 is 11, and then it's 11 over 4. Then the second method is writing decimals as fractions. For example, 0,125 we can write as 125 over 1,000. Then the third method is finding prime factors. Let's look at how to find the prime factors of 54. So we've got 54. Now the smallest number into 54 is 2, and it goes into 54 27 times. Then the smallest number into 27, or integer into 27, is 3, and it goes 9 times. The smallest number into 9 is 3, and it goes thrice. And then the smallest number into 3 is 3, and it goes once. So we continue in this way, dividing until we end up with 1. So now we can write 54 as 2 times 3 cubed. We have 3 3's over here. So these then are the prime factors of 54. We now get to more complex problems involving exponents. Example 1 deals with numeric expressions. Now, an expression is when we're asked to simplify or evaluate something as opposed to an equation. And you can see that these questions or problems all involve numbers only. So it's numerical. Let's look at the first one. 5 to the 0, of course, is 1 from the rules of exponents. Now, we have 9 over 16 to the negative a half. We can use prime factors. So I'm going to write 9 as prime factors. The smallest number into 9 is 3, and it goes thrice. Then into 3, 3 goes once. So we know that 9 is 3 squared. And similarly, we can get the prime factors of 16. The smallest number into 16 twice. It goes 8 times. The smallest number into 8, 2. It goes 4 times. Then 2 into 4 twice. And 2 into 2 once. So we can see that 16 can be written as 2 to the power 4. And this is to the power negative a half. I'm going to write the fifth root of 32 squared as 32 to the power of 2 over 5. So just writing the third as an exponent. Then we want to write this decimal as a fraction. So 0.125 we know is the same as 125 over 1,000. And we can simplify further 125 into itself once and into 1,000 8 times. So we know that 0.0125 can be written as an eighth. And this is to the power of negative 2/3. We can switch around this fraction and the power becomes positive. So to the power plus a half. Once again, we can use prime factors for 32. And we see that 32 is the same as 2 to the power 5. Of course, we're finding the prime factors of 32 very much in the same way as we did for 9 and 16. Here I can switch around the fraction, so it's 8 over 1, or just 8, and then the power becomes positive. Here we're going to multiply the powers, so 4 times a half is 2, and 2 times a half is 1. So just 3 in the denominator. Of course, we need a 2/5 here. Multiplying the powers here, the 5's cancel, and we've got 2 squared. Then we can use prime factors of 8 again, which is 2 cubed. Then 2 squared is 4, so it's 4 over 3, minus this 4 here. The 3's cancel here when we multiply the powers. So it's just going to be 2 squared. As we said, the 3's cancel here. So it's 2 squared, which is 4. Of course, these cancel. And we are left with 1 plus 4 over 3, which is 7 over 3. Let's look at number 2. What's important to note here is that we can't apply the -1 across the plus inside the brackets. We have to first simplify inside the brackets. So then, using the rules of exponents, we know that 2 to the -1 is a half. And of course, 2 squared is 4. And that's to the -1. We're going to write 1 1/3 as a proper fraction. So 3 times 1 is 3, plus 1 is 4. So it's 4 over 3, and that's squared. Then we can add a half and 4. So that's 4 1/2. And in writing 4 1/2 as a proper fraction, 2 times 4 is 8, plus 1 is 9. So it's 9 over 2. So we have 9 over 2 to the power -1. Then we can square out here. 4 squared is 16 and 3 squared is 9. Now we can invert this fraction and the power becomes positive. So it's 2 over 9 to the power of +1. And finally, we just add the two fractions. So that's going to be 18 over 9, which we know equals 2. Let's go to number 3. We're first going to get rid of the surd in the numerator. So we can write it as 24 to the power of 2/3. For the 18, we're going to use prime factors. So we have 18. The smallest number into 18 is 2, and it goes 9 times. The smallest number into 9 is 3, and it goes thrice. The smallest number into 3 is 3, and it goes once. So from this we can see that we can write 18 as 2 times 3 squared. And this is all to the power of a half. We can get rid of the surd here, so it's 2 to the half. And then we can find prime factors of 27 in the same way as we did over here. So that's going to be 3 cubed. and it's all to the power of negative a half, or negative a third rather. We can now also find the prime factors of 24. So we have 24. The smallest number into 24 is 2, and it goes 12 times. Then 2 into 12 goes 6. 2 into 6 goes thrice. And 3 into 3 goes once. So then we can write 24 as 2 cubed times 3. So 2 cubed times 3. Here we can apply the power to inside the brackets. Of course, we have a 1 here that we don't write. So that's going to be 1 times a half. So we have 2 to the power of a half. And then 2 times a half is 1. So we have 3 left. We can multiply out here the powers. 3 times negative a third is 3 to the negative 1. Now we can cancel some terms. These will cancel. So we're left with 2 cubed. Then 3 times 3 is 3 squared. Adding the powers. Of course, 2 cubed is 8. And we can subtract the powers of the 3's. So 2 minus 1 is 2 plus 1, which is 3. And we get 8 times 27. And this we can work out on a calculator. So 8 times 7 is 56. And that's going to give us 216. Coming to the last question here, it's important to realize that often there's more than one approach to solving a problem in exponents. We could start by subtracting the powers in this fraction here, where the bases are the same, or we could start by interchanging the 3 to the negative 1 and the 2 to the negative 2, and the powers would become positive. So perhaps we should do that. So we're going to take the 3 to the minus 1 into the denominator, and it becomes 3 to the plus 1, or just 3. Then 2 to the minus 2 goes to the top, and the power becomes positive. So it's 2 squared, and we still have 2 cubed and 3 squared. I'm going to take the 3 to the negative 2 into the denominator, and the power becomes positive. So it's going to be 2 over 3 squared. Now we can add the powers here in the numerator. So it's going to be 2 to the power of 2 plus 3. So 2 to the 5. And the same in the denominator. It's going to be 3 cubed. Then 3 squared, of course, is 9. 2 to the 5 is 32. And that's going to be over 27. Now we can find the LCD, which is 27. 27 into 27 once times the top is 32. 9 into 27 thrice times the top is 6. And we have an answer of 38 over 27. Please try this question before looking at the answers. So we're going to write 7 to the 0 as 1. We're going to get rid of the third here. This is 8 to the power 1. So it's going to be 8 to the 1 over 3. And here we're going to take the 2 to the negative 1 into the denominator. So it's going to be 3 over 2 to the 1, or just 3 over 2. Now we can use prime factors of 8. We know that 8 is 2 cubed using prime factors. We can multiply the powers here. So 3 times the third is 1. So we're left with 2 to the 1, or just 2. One plus 2 is 3, minus 1.5 is going to be 1.5, or 3 over 2. Let's look at the solution to the second question. So we can start by getting rid of the third here. So it's going to be 81 to the negative a quarter. Then anything to the power 0, of course, is 1. We're going to switch around this fraction, or invert it, so the power becomes positive. So it's to the power of plus a third. Now we're going to use prime factors of 81. The smallest number into 81 is 3. It goes 27 times. The smallest number into 27 is 3. It goes 9 times. The smallest number into 9, 3. It goes thrice. And then 3 into 3 once. So we see that 81 is 3 to the power 4. And this is all to the power of negative a quarter. Similarly, we can use prime factors of 27 and 8. We know 27 is 3 cubed and 8 is 2 cubed. This is all to the power of a third. We can multiply the powers here. 4 times negative a quarter is negative 1. And 3 times a third is 1. So it's just 3 in the numerator and 2 in the denominator. 3 times a third over here is 1. This is 1 over 3 to the 1, or just 1 over 3, plus 1 over 1, plus 3 over 2. We can find the LCD, which is 6. 3 into 6 twice times the numerator is 2. 1 into 6 6 times 1 is 6. And 2 into 6 thrice times 3 is 9. So it's 2 plus 6 is 8 plus 9 is 17 over 6. Let's look at the answer to the third question. We can't apply a square root across a plus or a minus. So we're going to simplify inside the square root. So it's going to be 5 squared, which is 25, minus 3 squared, and 3 squared is 9. Of course, we can write a 2 to the negative 4 in the denominator as 2 to the plus 4. And we can take the 2 to the negative 2 to the top, and the power becomes positive. so it's 2 squared. We're going to write 0.25 as a fraction, so it's 1 over a quarter. Note that 0.25 is 25 over 100, and 25 into itself once, into 100 4 times. This becomes the square root of 16. We can add the powers on top, so it's 2 to the 6 plus 2, and then subtract the bottom power, so minus 4. We know that the square root of 16 is 4. Of course, we could have done it in the following way. The square root of 16 is 16 to the power of 1 over 2. So 16 to the half, and then we could have worked out prime factors, which is 2 to the 4 for 16, all to the half, and 4 times a half is 2, which is 4. This is getting the square root of 16 step by step by using the rules of exponents. But it's easier to just go straight to 4 over here. 6 plus 2 is 8, minus 4 is 4. So we have 4 minus 2 to the 4 is 16 plus a quarter. And of course it's negative 12 plus a quarter, which is negative 11 and 3/4. And we can write it as a proper fraction. 11 times 4 is 44, plus 3 is 47 over 4. We can find the prime factors of 12 to start with. So if you look at 12, the smallest number to 12 is 2, and it goes 6 times. The smallest number to 6, 2, and it goes thrice. The smallest number into 3 is 3, and it goes once. So we can see that 12 is 2 squared times 3. So it's going to be 2 squared times 3, all to the power of a half. Here we can get rid of the third and write it as 18 to the power of 3 over 2. We can also get rid of the third here. It's going to be 8 to the power of 1 over 6 and 3 to the power of a half. We can apply the power to everything inside the brackets. So a half times 2 is 1, so it's just 2. And we have 3 to the half. We can also find the prime factors of 18. So we see that 18 is equal to 2 times 3 squared. We can find prime factors of 8, so it's 2 cubed, all to the power of 1 over 6. Now we have 2 times 3 to the half times, we can apply this power inside the brackets. And there's a 1 here that we don't write. So 1 times 3 over 2 is 3 over 2. And then 2 times 3 over 2, the 2's cancel, and we're left with 3 as a power. 3 times a sixth is a half. And we have 3 to the half left as well in the denominator. Now we can add the powers for terms that with the same base on top. So let's first consider the 2's. This is 2 to the 1. So it's going to be adding the powers. We're going to get 1 plus 3 over 2. And then minus the power in the denominator, so it's minus a half. Then adding and subtracting the powers of 3, we have a half plus 3. And subtracting the power of the denominator or in the denominator, so minus a half. We can simplify this. 1 plus 3 over 2 is 2.5, minus a half is 2. The halves cancel here, and we're left with 3 cubed. And this, of course, is 4 times 27, which is 108. Let's look at example 2. It deals with literal expressions. In other words, we now have letters in these expressions. Let's look at the first one. We're simply going to apply the power outside the brackets to each factor inside the brackets. Of course, there's a 1 here that we don't write. So then multiplying the powers, the power of 2 is 1. So 1 times 3 is 3. So 2 cubed. Then p minus 3 times 3 is 3p minus 9. And it's simply going to be 8 times x to the power of 3p minus 9. Let's look at the second one. We're going to find prime factors of 32 in the usual way. So that's going to be 2 to the 5. And then we have x to the negative 15, all to the power of 2 over 5. Then multiplying the powers, 5 times 2 over 5, the 5's cancel, and we're left with 2 squared. Minus 15 times 2 over 5, 5 into negative 15, negative 3 times 2 is negative 6. 2 squared, of course, is 4. And we can take this one step further by taking the x to the negative 6 into the denominator as x to the positive 6. Let's look at the third one. Here we're going to start by finding prime factors of 54. So we have 54. The smallest number into 54 is 2, and it goes 27 times. Then 3 goes into 27 9 times, 3 into 9 thrice, and 3 into 3 once. So 54 can be written as 2 times 3 cubed. And then we still have a to the 6, b to the 9. Now, there's a 1 here that we don't write. We're going to get rid of the third now. So it's 2 to the power of 1 over 3. Then 3 to the power of 3 over 3. So just 3 to the 1 or 3. Then 6 divided by 3 is 2. And 9 divided by 3 is 3. We're going to multiply the powers. A third times negative a half is negative a sixth. There's a 1 here that we don't write. So 1 times negative a half is negative a half. And 2 times negative a half is negative 1. 3 times negative a half is negative 3 over 2. Now, note that all the powers are negative, so we can write it as 1 over everything, and the powers become positive. And this is about as far as we can go. Let's now look at number 4. Once again, we can't apply the power outside the brackets across a plus. So we're going to first have to simplify inside the brackets. B to the negative 1 is 1 over b. We can get one fraction inside the brackets. Just note that this is a over 1. So the LCD is b. 1 into b, b times the top. b into b once times the top. And now we can simply invert the fraction. And we can square out. AB all squared is a squared b squared. Then we have the positive sign. AB times 1 is AB. Times 2 is 2ab, and then we have 1 squared, which is 1, and this will be our answer. Let's look at number 5. I'm going to rewrite the 3 to the 1 minus x, or rather 1 plus x. We're going to find prime factors of 24. So we have 24, 2 into 24, 12 times. Of course, 2 can go into 6. and 3 into 3 once. So then 24 we can write as 2 cubed times 3. And this, of course, is all to the power of x plus 2. Once again, we can find prime factors of 18, and we see that it comes to 3 squared times 2. And then prime factors of 4 will be 2 squared, all to the power x. We can simplify. We can multiply the powers here. So 3 times x plus 2 is 3x plus 6. And 1 times x plus 2 is x plus 2. In the denominator, 2 times x plus 1 is 2x plus 2. And we have 2 to the x plus 1. And 2 times x is 2x. We can now add and subtract powers of numbers with the same base. So it's going to be 3 to the 1 plus x minus, or rather plus, x plus 2. And then minus 2x plus 2, which is minus 2x minus 2. Then we have 3x plus 6 and minus x plus 1. So it's minus x minus 1 and then minus 2x. Let's simplify this. Of course, here the 2's will cancel. We have x plus x is 2x minus 2x. So the x's also cancel. And we're left with 3 to the 1, or just 3. Then the powers of x, we have 3x minus x is 2x. Minus 2x is 0, so the x's here cancel as well. And then 6 minus 1 is 5. So we have 3 times 32, 2 to the 5 being 32. And that, of course, is 96. Please try this question before looking at the answers. Let's look at the first question. We could do this in more than one way. We could invert this entire term so that the power becomes positive. Or we could first multiply the powers inside the brackets with the power outside. I'm going to go with the first option for no particular reason. So we invert the term. So it's going to be 5a cubed b squared all to the power of plus 2. Now we can multiply the exponents. So it's 5 squared, a to the 6th, b to the 4, and this of course is 1 over 25, a to the 6th, b to the 4. Let's look at the second question. So number 2, here we have 16x squared, y to the negative 6, all to the plus a half. We can use prime factors of 16. So it's going to be 2 to the 4. Now we can multiply the powers. 4 times a half is 2. 2 times a half is 1. And negative 6 times a half is negative 3. 2 squared, of course, is 4. And we can take the y to the negative 3 into the denominator as y cubed. Let's look at the third one. We can first find prime factors of 12, and we can see that it's 3 times 2 squared when we work it out. Now we can get rid of the surd inside the brackets. So there's a 1 here that we don't write. So it's 3 to the power of a half. Then 2 divided by 2 is 1. So just 2 to the 1. And then also p q squared. So 4 divided by 2 is 2. We can now multiply the powers. So it's going to be 3. A half times negative 3 is negative 3 over 2. 1 times negative 3 is negative 3, and we have p to the negative 3, q to the negative 6. We can now write it as 1 over, and all the powers become positive. So 3 to the plus 3 over 2 times 2 cubed times p cubed times q to the 6th. Two cubed is 8, so it's 8 times 3 to the 3 over 2, p cubed times q to the 6th. Let's go to number 4 now. Here we have the cube root of 8a cubed, b to the 6th, all squared. Once again, we can find prime factors of 8 to start with. We can get rid of the surd here. So 3 divided by 3 is 1, so it's just 2. And the same with the a. And 6 divided by 3 is 2. And this is all squared. Now we can multiply the powers. So we'll have 1 times 2 is 2. So we have 2 squared, which is 4. And we have a 1 here that we don't write. So 1 times 2 is 2. And then b to the 4.